And here we are in the last section of Chapter 2. Section 8 is Linear and Absolute Value Inequalities. And it's actually going to be graphing them rather than solving them. So we'll start with these steps. The first step is that you are going to graph the line or absolute value like you normally would. So there are a couple of strategies that I just kind of want to remind you about. If you have a line, you need to kind of consider whether it is in slope-intercept form or in standard form. Slope-intercept form, remember, looks like y equals mx plus b. And to graph that, you are going to put a point at 0b, which will be the y-intercept. And then you are going to use the slope, which would be rise over run, to get more points. Then you'll connect those in a straight line. Remember that a positive slope is going to slope up right to left, negative slope slopes down right to left. You might also have a line that is in standard form. The standard form lines are ax plus by equals c. And remember to graph those, we use the cover-up method. So we cover up the y term, divide both sides by a to get the x ordered pair x0, cover up the ax, divide both sides by that b to get the 0 y point. So I will just say use cover-up method. And if you're not sure how to graph these lines, go back to the notes for the graphing line section or come in and get some help so that we make sure that we know how to graph those lines. Absolute value graphs. Those are the ones that have the absolute value bars in them. And remember that we are going to use the vertex is the start point. And normally the vertex is at 0, 0, but remember that it can move based on the left or right shifts, which come from inside the absolute value. And it could move based on the up and down shifts, which are after the absolute value. And then to graph, we use the pattern over 1, up 1. Then we go back to the vertex, go over 2, up 2, go back to the vertex, over 3, up 3. And then if there's a number out front, remember we multiply by the number in front. And if that number is negative, that's going to make our absolute value function open down. So remember, if you have a negative out front, then your absolute value is going to open down. So you would change all of these ups to downs. Now, before you connect the dots on your lines or your absolute values, you need to look at the symbol that you have. So the second thing to consider is whether you're going to use a solid line to connect your dots or use a dashed line to connect your dots. So you're going to use a solid line if your inequality was less than equal or greater than equal. You'll use a dashed line if your inequality was less than or greater than. And the third thing that we need to do, which is different from regular graphing, is we are going to shade. So anytime you see an inequality, whether it's an absolute value or a linear inequality, and you're graphing it, you need to make sure that you are shading somewhere. So the way that we determine how to shade is we are going to test a point that is not on the line or absolute value. So it has to be a point that was not connected by your slope or your absolute value curve, or absolute value v. Test a point by subbing into the original, so I'll say substituting into the original inequality. You're going to work it all the way out. So you'll end up with a number on the left and a number on the right of your inequality. And that inequality is either going to be true. For example, 5 is greater than 4, or it is going to be false. For example, 4 is greater than 5. If your inequality is true, then you're going to shade on the side of your test point. So let's say that my graph was a line, and I chose a test point over here that is not on my line. If my inequality comes out true, like 5 is greater than 4, then you're going to shade on the side that your test point was on. So in this case, I will be shading everywhere that's on this side of my line, like that. If my inequality comes out false, like 4 is greater than 5, let's say I still chose a test point over here, but my test point came out false, then I will shade on the side opposite my test point. So if it comes out true, shade on the side with the test point. If it comes out false, shade on the side opposite the test point. And we'll work through a couple of examples so you can see what it looks like when it comes out true and false. All right. Y is less than negative 2/3 x plus 4. First of all, is this a line or an absolute value? Since there's no bars in it, and there's no squareds or anything, this is a line. And it's in slope-intercept form. So I'm going to graph my y-intercept at 0, 4, and then my slope is going to be negative 2/3. I'll put my y-intercept at 4 and then use the slope of negative 2/3. So I'm rising by 2 and running by 3, making sure it slopes down. So 2, 1, 2, 3, 1, 2, 1. Nope, I need more tick marks. 1, 2, 1, 2, 3. Okay. Now before I draw my line, I need to decide if it's going to be solid or dashed. So I look at my symbol, less than and greater than. If you look back, this kind of symbol with no line underneath would be a dashed line. So I'm going to connect my line, my dots using a dashed line. And then I have to remember to shade. But before I can shade, I need to choose a test point. So I'll pick a point not on the line. It could be any point I want. People tend to like the point 0, 0. 1, 1 also works. The only ones you can't choose are the ones that are right along this line. So if I test 0, 0, then I plug in 0 for y, and I go 0 is less than negative 2/3, and I put in 0 for x plus 4. And then I work that out, keep the left side 0, multiply negative 2/3 times 0 is 0, plus 4, and I get 0 is less than 4. So I should see this testing when you're doing your exercises. I should see your graph, and I should see the testing, and whether that's true or false, and then I should see that you would shade. Since it is true, I shade on the side of my test point. So I'm going to shade this line down below. You don't have to color the whole entire thing in, but I should definitely be able to tell where you have shaded. Let's look at some more. How about 2x minus 3y greater than or equal to 12? Again, we've got to decide what kind of graph it is. I don't see any bars in it or squares or anything like that. So this guy's a line. And all my variables are on the left and my constants on the right, which means it's in standard form. So to graph this by the cover-up method, I'm going to cover up the minus 3y, and I actually go ahead and write 2x equals 12 instead of greater than or equal. Just do 2x equals 12, which gives me x equals 6, so that ordered pair is going to be 6, 0, and then cover up the x term. That's going to give me negative 3y equals 12. Divide both sides by negative 3. So y is negative 4, which gives me an ordered pair 0, negative 4. So with a standard form equation, I'm just going to graph these two ordered pairs, and then I'll be connecting them. So I'll put the ordered pair 6, 0 right here, the ordered pair 0, negative 4 right there, and then I'm going to connect those. I need to know if it is a solid or dashed line, and to tell that, I wanted to label that dashed line. To tell what kind I have, I look at my symbol, and since it says greater than or equal to, remember back here, the two that have the equal to's are a solid line, so this tells me it's a solid boundary line. So go ahead and connect those with a solid line. And then I have to remember that I'm going to need to shade. So I'm going to choose a test point. Remember, it can be any point as long as it's not a point that's on this line. 0, 0 seems to be a favorite, so I will test 0, 0, which means I'm going to replace the x with a 0 and the y with a 0. So So I'll have 2 times 0 minus 3 times 0, and then greater than or equal to 12. Work that out. 2 times 0 is 0. 3 times 0 is 0. 0 is greater than or equal to 12. That is false. So when you get a false response like that, that means I am not going to shade here. So I can't shade anywhere on that side that contains the test point. So I'm going to shade on the other side, which will be down below this line. How about an absolute value equation? Or excuse me, inequality. F of x is less than 3, absolute value x plus 2, minus 1. So this one is an absolute value graph. I can tell because it has those absolute value bars. And remember, to graph those, we have to say where the vertex is. Normally it's at 0, 0, but inside here, x plus 2 tells me I'm going to shift to the left 2, and the minus 1 at the end tells me I'm going to shift down 1. So the vertex for this absolute value will be at -2, -1. And then normally I would go over 1, up 1, over 2, up 2, over 3, up 3. But I have a stretch out front of 3, so multiply all my ups by 3. And I will be going over 1 up 3, over 2 up 6, over 3 up 9. So I'll put my vertex on at -2, -1, and then go over 1, up 3, go back to the vertex, go over 2, up 6, and then back to the vertex, over 3, up 9. And then I'll have those same points on the other side of the vertex. And I need to look and see, is this going to be a solid connecting line or is it going to be dashed? Remember that solid lines are the ones that are equal to, dashed lines are the ones that are just less than or greater than. So this is telling me it's going to be a dashed absolute value. So when I go to connect these dots, I want to make sure that I use a dashed line and that everyone can tell it's a dashed line. I'll put my arrows on the end. And then because it's an inequality, I'm going to need to test a point and then shade. So absolute value graphs are a bit different than lines. Lines have kind of like a either above or below or left and right, however you want to look at it. Absolute values kind of have their two sides are not above and below or left and right. Their two sides are inside and outside. So you want to pick a test point that's either inside the absolute value graph or outside it. And remember, it can't be on the V itself. You're certainly still welcome to choose 0, 0, and that should work out just fine for you. You just need to make sure that you're showing your work of substituting in. F of x is a fancy way of saying y. So when I have f of x here, that just means my y value. So I'm going to choose 0 is less than 3 times the absolute value of x, but it's a 0 now, plus 2 absolute value minus 1. There's nothing to work out on the left side, so I just continue that with 0 is less than. And then I'm going to do the work inside the absolute value bars first by order of operations. So it'll be 3 times the absolute value of 2 minus 1. Then I take the absolute value of 2, which is still 2, so 3 times 2 minus 1. And then I do my multiplying, so 0 is less than 6 minus 1. And then my subtraction, 0 is less than 5. Now it is true that 0 is less than 5, so I'm going to take where my test point is, right here, and I'm going to shade on the side of my test point. So in this case, the side of my test point means the outside of the absolute value, not the inside. So I'm actually going to shade all of this that is outside the absolute value bar, and just don't shade the inside. This will be our last example with absolute value inequalities. It's going to be f of x is less than or equal to negative absolute value of x. So again, this is an absolute value graph. You can tell because it has those bars in it. The only transformation I have here is this negative out front, which means it reflects over the x-axis. In other words, it's going to be upside down. So I will have my vertex at its normal spot of 0, 0, and then my pattern will go over 1, and I will go down 1, over 2, down 2, over 3, down 3, instead of over and up because it's flipped upside down. Looking at my symbol here, that's less than or equal to, which tells me it's going to be solid. We'll put the vertex at 0, 0, over 1, down 1, back to the vertex, over 2, down 2, back to the vertex, over 3, down 3. And then those same points on the other side. And I'm connecting these with a solid line. Now I just need to pick a test point and then shade. Now on our other graphs we were choosing 0, 0, which worked out real well for us, but on this graph we can't choose 0, 0 because 0, 0 is a part of my graph. So I have to choose some other point. So I'm just going to kind of randomly choose a point out here at 3, 1 for my test point. So I'm going to test 3, 1. So that my y value is 1 and my x value is 3. So I'll put in for f of x, remember means y, so I'm going to have y, which is 1, is less than or equal to negative absolute value of 3. Now there's no work to do on the left, so it stays 1 is less than or equal to. On the right side, I'm going to start by taking the absolute value of 3, which would be 3, so I have negative 3. And that's really all the work I have. 1 is less than or equal to negative 3. 1 is actually bigger than negative 3, so that ends up being false. So since my test point is over here, which is on which side of the absolute value? The outside of the absolute value. Then I will shade on the other side, which is the inside of the absolute value. So this one is going to be shaded inside the absolute value sign, the absolute value graph.